Our next speaker is Simon McCormick from Echelon Data Centers. Simon is the Chief Technical Officer at Echelon. He has managed and delivered data center projects in Ireland, Europe, and the Middle East for a variety of cloud service providers, co-location providers, and enterprise end users. Simon joined Echelon after 4 years at a global engineering firm where he was part of the data center leadership team. He is a chartered member of the ICE, the RICS, and CIOB, and has worked both in contractor and consultant side. Simon came to us through working with Rory Monaghan in NUIG, and it's about how we now use hydrogen moving forward. Simon, over to yourself. Thank you.
Thanks very much, Paul, and thanks very much, everyone, for attending the attending the webinar today. A little bit about Echelon Data Centers to begin with. We're an infrastructure developer, and what we're trying to do is support the growing demand for data storage and compute power globally. I think we can all appreciate that over the past year and a little bit more that's grown quite significantly, and we're doing our part in that. This was just to make clear, we're not a Google or an Oracle or an IBM. We deliver the physical assets for companies like those to run their programs and store their data and things like that. I mentioned that because the name says Echelon Data Centers, but we are very much focused on the nuts and bolts of how this fits together. And I suppose critically for this conversation today, we're focused on how those facilities get powered as well. A big part of our mission statement, if I can put it that way, is that we develop sustainable assets. And again, it's important for me to emphasize that when we talk about sustainable assets, we talk about real, tangible, impactful measures. There's plenty of our peers that will do smaller piecemeal tasks or actions to improve their credentials. What you might almost term greenwashing. But we're really focused on what the big ticket items are and what's really going to move the needle. I'll talk about some of that later in the presentation, but just one that's hot off the press at the moment is that we've announced a partnership with Biocore Environmental yesterday, and we're gonna develop an AD plant on one of our sites, which in turn is going to generate some biogas for us to consume in powering the data centers. So, rather than just talking about putting solar panels on the roof or providing EV points, all good stuff, by the way, and definitely helps. We're also looking at the bigger items, as I said, that are gonna be able to move the needle. A little bit about myself. I'm the CTO at Echelon, as Paul said. That means that I'm responsible for the strategic technical direction of Echelon, the products that go into our data centers, but also how we operate them. Again, that's relevant to today's conversation because a big part of it is how we power those facilities. So I obviously forgot to click on the slides there. Apologies for that. I'll just jump to the next one. The strategic side of things is probably the best place to start because I want to give some context to all of this. What I guess I'm trying to get across to the audience here is that for us this isn't a fad. We're not talking about hydrogen, and we're not talking about renewable energy, and we're not talking about sustainability just because it seems to be the thing that's on everyone's lips at the moment. We see there being real social, economic, and environmental benefits for us as a business, but also the communities in which we deliver our projects in, and the communities in which we serve. So I've got a graphic there which just illustrates that there are a couple of macro policies or I guess macro schemes, if you like, that are in place on the island of Ireland at the moment. I guess maybe the graphic is a little bit misrepresentative, but I guess what I'm trying to say is that Echelon Data Centers has a role in all of those policies, as in we're impacted by all of those policies. So just to rattle through them very quickly, there's a government statement from the Government of Ireland in 2018, which talks about the long-term support the government has for data center development in Ireland as being part of a driver for economic growth. We have the renewable energy development plan. The offshore renewable energy development plan, primarily focusing on wind and the government support for that from 2014. We have tomorrow's energy scenarios from EirGrid, the transmission system operator in the southern part of the island of Ireland, which talks about the need to relocate, as Paul mentioned at the beginning, the need to relocate data centers outside of urban environments, closer to sources of renewable energy. And last but by no means least, we have a connection policy, again from the transmission system operator EirGrid in Ireland, which asks that, creates a condition that for data centers to be given connection agreements, as in connections to the national grid going forward, they're going to have some form of on-site generation. So that's the big picture. Data centers, good. Offshore wind, good. Being located outside of the urban environments, beside sources of renewable energy, good. A requirement to have on-site generation, not necessarily good, but required anyway. There's a slight conflict in all of that, as you can imagine. On-site generation, okay, is to do it reliably, if I can put it that way first, for data centers, generally means running off some sort of fossil fuel. Not so much diesel, but more likely to be natural gas. You could take the policy to mean that on-site generation should be wind or solar. But as anyone that's ever been near or worked in the data center industry, you'll know that that's not appropriate because of the non-synchronous nature of that. So people have tended to go for gas. So there's an inherent conflict in all those strategies, and that's something that we're trying to solve. So that was the strategic level, if you like. Let me talk about the tactical level. So again, in the context of big, impactful, needle-moving tasks or actions, we announced a joint venture with SSE Renewables last year. So this is to connect the second phase of the Arklow Wind Bank project into our site, into the substation that's on our site in 2025. Now that scheme, when it's delivered, is going to generate somewhere between 600 and 800 megawatts of wind energy, more than we can consume as a data center customer on the site. So there'll be a large portion being exported to the grid. But we also have to, I suppose, as part of that, we also have to take cognizance of the need to curtail some of that. So, as Mark mentioned in his presentation at the beginning, a significant amount of renewable energy is curtailed on the island each year. The latest statistic for 2020 is that 1.91 terawatt hours of wind was curtailed. Okay, so while we have all these great objectives and great schemes that are going on, there's still a problem to be solved in all of that. What do we do with the excess wind? And then I guess the inverse of that problem, what do we do when we don't have wind and we still need to consume energy. Again, maybe more towards Robert's presentation. Batteries have helped with a large part of that, for sure, particularly in shorter duration storage. And while battery technology is improving and we are getting longer durations, it's just it's unlikely. Sorry, it's hard to see in the short term that we get to the volume of storage that we're going to require to go through 3, 4, 5 days of being without wind, which is possible. Okay, so battery storage is great for the high frequency, or sorry, the rapid response, and there is absolutely a role for batteries to play, but multi-battery, multi-day storage just doesn't seem to be available to us at the moment. I guess tactically, then, where that's led us to is, and I'm glad I've gone third in the order of things. Our outlook as Echelon Data Centers is really a combination of what Mark and Robert have talked about already. So Mark talked about converting the wind energy into hydrogen. Robert has talked about the actual consumption of hydrogen. That's happening at the moment. It's up and running. We're a little bit behind that, but we're actually combining those two ideas, right? We're combining the production, the storage, and the consumption into one process, if you like, at one location. The other point that's worth noting is that we're planning to consume the hydrogen via internal combustion engines. So I know Robert talked a lot about fuel cells, and he mentioned that that he had done some work on the internal combustion engine side of things as well. That's where our focus is. So we are behind Energy and Wrightbus at the moment, for sure, in terms of getting our project up and running. On the flip side of that, though, we're, apart from the hydrogen production itself, we're going to be relying on technology that's readily available in the market at the moment. So I've talked briefly about strategic. I've talked briefly about tactical, operational. So this really leads us to the proposed development that we have. We're targeting 2022 to have some form of this up and running, whether we call it a pilot or a proof of concept. But we plan to have a multi-megawatt scheme in operation next year. This is down in our Arklow site, just on the east coast of Ireland, about an hour south of Dublin itself. So we've got a large scale industrial zone site. We've got a significant number of renewable generators nearby. So not just SSE that I talked about, and the potential that we connect that in. We have a number of other generators nearby, which can supply the renewable energy that we'll need for the green hydrogen. We've got a data center with a large steady state demand. We've access to a nearby water course for our cooling. We've got the grid connection. We've got one there at the moment. We've got another one planned, and I guess importantly, we've got access to market ready hydrogen engines as well. Depending on which manufacturer you talk to, that's a simple modification to the manifolds and the valves. Some others, it's a little bit more complicated, but I guess the general gist of it is that it's here now, and could be produced at a larger scale. The missing piece of the puzzle, I want to say missing. We are talking to manufacturers, to producers at the moment on the hydrogen side of things, but that's probably the bit that we obviously need to get our head around the most. I mean, the other sort of half dozen points that I've listed there, that's bread and butter for us in terms of buying engines, buying sites, setting it up, developing data centers. That's all fine. The hydrogen bit is obviously the tricky bit, and that's where we'll spend our time and our money over the next year or so. So the plan, as I said, is to get the pilot up and running by the end of, let's say, Q2 next year. That's going to be a multi-engine, multi-megawatt type setup. We'll provision for a couple of days of storage, and that should be enough to demonstrate that we can run the data center off renewable energy directly, and for periods of low supply, that we can use the hydrogen as the energy release. So yeah, a little bit of this is looking into the future and bringing a concept to life that doesn't exist at the moment. At the same time, we really feel that we're just reassembling products or processes that already exist, just in an innovative way. So the time to market and the time to realization of this as a plan should be relatively short in the grand scheme of things. So with that, I'll hand it back to Paul for some questions. I know we're approaching the end of our slot here, so yeah, happy to take some questions, Paul.
Simon, excellent. And you've raised a lot of questions here, because we're comfortable with hydrogen. We're getting there. We're comfortable with hydrogen in buses. It's now becoming reality. But now you're introducing a new concept. And it's great to see some of the questions coming through, which will take you. But one of the things I'll address to you, first of all, you don't mind. You talk about production, storage, and consumption being combined. Does that now give you an opportunity to take your data centers, what I would call decentralized, away from areas of population, and bring into areas of renewable opportunity? So you're reversing the energy grid to you can go where you need to go, where you get the energy opportunity, rather than have to tie to the East Coast. The reason I asked that question is the site that you're highlighting there in Arklow. You're regenerating an old site that was Irish Fertilizer that closed down, that led to a lot of community unemployment. You're now helping revitalise a community by bringing hydrogen to the site.
Yeah, that's right. So two things there, Paul, to pick up on. One is, as I mentioned at the beginning, we've got air grids document tomorrow's energy scenarios. So that's from October 2019, and it explicitly calls out locating data centers to areas of lower, let's call it non-data center demand. So getting them away from the M50 ring that runs around Dublin, getting them away from there, getting them to areas of large scale renewables. Absolutely. The second point that you make there is, yeah, there's a great story. There's a great story to tell for sure, but it's as I said, real tangible benefits in there for the regeneration of an area that had benefited so much from industry being there, had fallen on hard times, as you said, and the opportunity to repurpose that and breathe new life into it, and definitely have it take part in the newer elements of the economy, data centers being one, hydrogen being another. I'll just add, whenever we first began to develop this site, just a little over 3 years, we were told we were mad. No one would move outside of Dublin with the data center. Nobody would be interested in your renewable energy story. And 3 years down the line, it's a completely different deal now. We've got very real interest from global data center customers, and we really think we've got a huge opportunity here to for Ireland Inc., if you like, to demonstrate that this is a working and viable way to follow through on their policy for support for data centers.
Excellent. Folks, we'll take another couple of questions specifically for Simon, but we'll ask the audience also to keep your questions coming for the next couple of minutes, because we'll go on 10 minutes beyond the threshold at 11:30, and we'll have the gathered Q&A. Question for you there, Simon, is from Dr. Bodo Gross. How does the area required for storage of hydrogen compare to storing diesel for a similar capacity period, i.e. 48 hours backup power?
Hi, Barry. How are things? Yeah, so that's something we're trying to work through at the moment. So we can. The answer is it's bigger, right? Okay, first and foremost, if we were to not compress the hydrogen, to cut down on the volume, it's going to be bigger than the diesel. If we do invest that a little bit more in the infrastructure and the processes, we can compress the hydrogen into an equal volume for diesel, or if not a smaller volume. So it's another step in the process, but that is absolutely achievable. One thing we've all got to bear in mind, and let's say it, when it comes to data centers, diesel is very much the norm. Diesel is not a particularly volatile substance. It's plenty clean. You could throw a lit match into it and it wouldn't catch fire. I'm not sure I want to test that. Hydrogen obviously is a different substance altogether. So I guess the protections and the I guess the physical barriers we put around it is something we're going to have to think about carefully as we go forward with this.
And on a similar vein, question from Barry McMullen. For the Echelon project, can you state the planned hydrogen energy storage capacity on the site, gigawatt hours?
I cannot. I'm gonna have to. I'm happy to come back on that one. I just don't have that at my fingertips at the moment.
No problem. And the final question before we move to the main group, and it's a question from Abigail Dombey, is there any reason why you're not looking at hydrogen fuel cell generators?
Yeah, so it's a good question. One is, yes, I think in the longer term, it makes sense that's probably the answer. And for example, Microsoft has started trialing that in the United States. The initial feedback is that it's quite expensive. I suppose what we're trying to achieve is, if I can use the expression, this is a low hanging fruit for us to be able to generate the gas. The production of the gas is probably the only part that's atypical, if I can put it that way. At the moment, everything else is fairly typical. So gas, combustion engines, as I said, that'll be bread and butter. All the electrical equipment and things like that's all fairly standard. The point I'm trying to get to with that is that the speed to market and being able to get up and running sooner rather than later is the key to this, while in parallel developing the fuel cells idea. So it's not an either or in our mind. It's let's do this first because it's the easiest, and it'll get us on the path that we want to be, while we've got the time then to figure out the fuel cells question.